Hello friends, my name is Syed Irfan Ali and I made this loop function calibrator. Basically, to ease my activities while I was having lots of work of loop testing activities and function test activities, and to during these activities we have to do many calculations, and we have to inform the field technician to apply certain values, and that value should be accurate. And many times we have to uh, ask him to give certain percentage so that we get some alarm on DCS. And there are different kinds of alarms like low alarm, low alarm, high alarm. So every time we have to calculate, and it takes time. So if we have lots of activities, so this application is very useful and you can do it very fast. You can complete your loop activities and function activities very fast. So we will see how it works. So I have already installed this app on my device, and we'll see. Let's open it. So when we open it, we see uh, I have provided you can close the ads, or you can click on the ads to support my work, because Google does not pay anything if people don't click. You don't need to install, but you just need to click, and then you don't install it all. Okay, now we'll see the first calculation. This is loop calculation. This is generally used calculations like percentage to milliamp converter. So when we are in the DCS station and we want the field technician to say that apply certain amount of uh, give me this much percentage. So if it is hard device, then we have to tell him how many milliamps he should apply from there. Okay, for example, if I apply 25%, then if I want 25% on the DCS scale for linear calculations, then you should apply 8 milliamps. Similarly, if I want 50% on the display DCS display, then I should tell uh, the technician to apply 12 milliamps. If I apply 75, if I want 75%, then I should tell the technician to apply 16 milliamps. And if I want 100% value, then he should apply 20 milliamps. The same calculations can be used in case of walls. When you want to calibrate the wall, then you want to apply certain amount of milliamps to stroke the wall. So when you want to see the wall at 25%, you need to apply 8 milliamps. And when you want to when you want the wall to move 50%, then you need to apply 12 milliamps. When you want wall to be at 75%, you need to apply 16 milliamps. And when you want the wall to be open 100%, then you need to apply 20 milliamps. So this calculation you can use in different places. Now second one is the flow square root calculation. Flow square root calculation, basically uh, it tells you how much amount of pressure. This is basically for DP type flow transmitter. Okay, if you are using DP type flow transmitter, it means the person has to apply certain amount of pressure from the field, and you will see the flow on the DCS or PLC in your HMI. Okay, so if if the technician applies 25% differential pressure on the field, then you will see 50% flow reading. Okay, and if he applies 50% of differential pressure on the transmitter, then you will see 70% flow, 70.71 to be exact. And when he applies 75% differential pressure over there, then you will see 86.6% in your flow scale. Okay, and if he applies 100%, then you will see the 100%. So basically this is um, in DP type flow calculation, there is square root calculation. So it will apply that square root calculation values, and then it will give you the exact amount how much it should be. Okay, and then there is RTD calculations. When we are when we want to calibrate temperature transmitter using and we are having RTD as a temperature element, then we should know that what amount of ohm we are getting, we will be getting if the temperature of the temperature the RTD is sensing is some values like, let's say, 20%, 20 degrees centigrade. So let's say if I apply 20, if the temperature is 20 degrees centigrade sensed by RTD, then 107.7 ohms I should get. Okay, if the temperature sensed by the RTD is 50 degrees centigrade, then we should get 119.25 ohms. Okay, if the temperature sensed by RTD is 100 degrees centigrade, then I should get 138.5 ohms. So this is the first basic calculations. And when we go to the next page, here we can see we have flow alarm milliamp calculator. This is very useful, very useful. I have used in various activities, in function test activities. So it eases your work and it makes your work very fast. Okay, so now we will see what are the values we need to get the output. Okay, so this is basically flow alarm milliamp calculator. Okay, so first value we need is the enter transmitter LRV. LRV is lower range value. Normally LRV will be 0 and there is a URV. URV is 100. So LRV and URV basically means LRV is the lower range value. It could be 0 or it could be some other values also, depending on your application, your calibration. And then there is URV. URV is the 100% value. So what this value again will be varied as per your calculation. Okay, so now we will take a sample calculation. If my transmitter is differential pressure type transmitter and it has the range of 0 to 250 ambar, so 0 to 250 ambar, and the my on my DCS we are getting the, let's say, 12 s meter cube per hour flow is there, and the lower is the 0 and the high maximum flow is 12 standard meter cube per hour. Okay, now I want to know if my alarm is at 4.8 standard meter cube per hour, so how much milliamps I should apply to the transmitter to be able to show to the client that this much, to show the client that the alarm reached. Okay, it may be low alarm, high alarm, low alarm, high alarm. Whatever value you will put, you will get the calculation. Now we'll see they calculate the milliamps and differential pressure to be applied to see the 4.8 value on the DCS. So now we calculated, we can see if it is a hard type transmitter, you can apply 6.56 milliamps, and if it is a FF transmitter, then you have to apply 40 mbar pressure. So I think it is quite easy. Now you don't have to be worried that you made any calculation mistake, and you are, if there is some calculation mistake, then definitely company will lose some amount. For example, if there is, if you go to the petrol pump and you are filling the petrol, okay, the the vendor is filling the petrol, but the flow meter is not calculating properly. So what will happen? Either you will get more petrol and there that will be the loss of the uh, petrol pump owner, or you might be getting the low petrol, less petrol, but it is showing more on the screen. So you might be losing at that time. So our calculation should be correct. That's why it is very much important. Now, for the second uh, calculation, there we can also calculate level alarm milliamp calculator. So this is basically if you are using DP type transmitter in uh, for level measurement of the tanks. Okay, so again I will show you the similar values. I'll put the same. Maybe I'm utilizing the similar transmitter which is also having 250 ambar, 0 to 250 ambar calibration range, and I'm again, my tank level is 12 meter or 12 feet, whatever you can consider. Okay, now I want to see how much will be the value if I have set the alarm level alarm at 4.8. So if level reaches 4.8, I should get some alarm. So how much, to simulate that alarm, how much value of milliamps or pressure I should apply, I will see this here. Okay, so I'll press the calculate milliamps at differential pressure. So here you can see, to simulate 4.8 feet level or 4.8 inches or whatever values unit you might be using, or 4.8 meter. Okay, so you will have to apply 10.4 milliamps, and the applied pressure will be, either you can use the you can simulate using loop calibrator, and you can apply 10.4 milliamps, and when you will apply 10.4 milliamps, you will see the 4.8 value on the DCS or HMI screen, or if you are using PLC, in that case PLC. Okay, and if it's a FF transmitter, or if you want to simulate using hand pump or digital pressure calibrator, so you have to apply 100, 99.999, or you can say 100 ambar pressure to get the level. Now if you see the two calculations, I used the same values. The transmitter range is 0 to 250, the URV and LRV uh, on the DCS is same. Okay, and I want the same value, same alarm value, which is 4.8. So here you can see, when I gave 4.8 at both places, so our input data is same, but the milliamps in both are different. So in case of this is because of, in flow calculations, when we are using the DP type flow calculation, it is based on square root calculation. So that's why uh, the values will be different. Okay, now we will see the other one. uh, okay, FGS raw count calculator. So when you are calibrating, um, or when you want to uh, do the function test of FGS, you need to apply certain amount of milliamps in the field so that you get the uh, values you should on the FGS station. Okay, now normally it is the range is 0 to 3276 in terms of count. Okay, okay, now if I'm using the H2S gas transmitter, okay, AGT, so for 10 ppm, 10 ppm is the high alarm. So if I use 10 ppm, how much milliamps will I have to give in the field? I can give 5.6 milliamps, or if I want to simulate it from safety builder or from safety builder, then I need to apply 917.28 raw count. Okay, when I give the 917.28, when I simulate this value in the safety builder, then you will see the 10 ppm alarm. Okay, 10 ppm alarm in the FGS station. Okay, our high range is, this is high, and at 40 ppm our the FGS station should sound high alarm. Okay, so at 40 ppm, how much milliamps we need to apply? We need to apply 10.4 milliamps from the field, or we need, if we are simulating it from the safety builder, then we need to apply 1703.5 count, or in to be uh, you can use 1704 also. So this will solve your issue. Okay, uh, regarding the pressure temperature compensation flow calculation, we'll come back to it later. Okay, then we have more calculations like vibration monitoring system, VMS, millivolt calculator. Okay, now we want to apply some millivolts so that we get some values in micron in the VMS station. Okay, so VMS HMI, normally we are using Bentley Nevada 3500. Okay, so uh, in case of vibration, if I apply 45 micron, I want to see the 45 micron. So how much millivolt I should apply? So let's calculate. When I click here, I get 127.298 or 128 millivolts. If you apply, you will get approximately 45 microns in the VMS screen. Okay,